My talk is the top 10 signs of the Textpocalypse, which aside from being actually a rather difficult word to enunciate correctly, is a really funny name. And what's the point of the talk, you might ask? Well, we wanted to talk about text. That's the business I've been in for the last 20-odd years. We wanted to pay a bit of an homage to David Letterman, who just retired after something more than the 20 years I've been in this business. And so we thought that we could title the talk, Stupid Text Tricks. Somehow that seemed bad. So instead, we have a top 10 list, the top 10 signs of the Textpocalypse. What does that mean? It means if you're used to working with data and you're at this conference, I'm going to assume you have some familiarity or interest in working with data. There's a reasonable chance you have, currently are, or plan to work with the kind of data that comes out of databases, gets stored in databases, this numeric structured information that people think of when they use the word data. Text is also data, or at least we like to think so because we're in the business. And we wanted to enumerate a few, 10 ways in which you have to think differently about how data works when it's textual data. And that's about the point where I really could use some slide help. I'm going to go with slides you guys can't see. No one says thank you. That's way down. All right, so starting out, what makes text different? By text, I mean textual information that's, or textual representation of something that was created by humans. And that's the first part of the answer to what makes it interesting and or different, in that text is human communication, the kind that we care about. Obviously, you can have computer-generated text. I'm going to focus on the human-generated text. Human-generated text is so-called unstructured. It's not unstructured at all. It follows the laws or generally follows the rules of human language grammar. But those rules are complicated, ambiguous, hard to follow, and often not followed. So that's one way text is very different from numeric data. You can pretty much rely on an Excel database row to mean what it's supposed to mean, or a relational database. So there's one big difference. The other really important difference about text is that it's a representation of something that's up here. When people write text, be it an electronic health record, a blog post, God forbid even a tweet, they're telling you something. They're conveying information. And in the fields of marketing or public health or just about anything else, you often care. You want to know something about what people are thinking, what's going on inside their heads. In order to do that, you could ask them to enter some numbers into a survey form, or you could try to attempt to read and get value from their text. That's actually mine. Technically, it's his. See, it's going the other way. All right, give me a second. Nope. All right, where is that? Is that there? Whoa, that can't be right. 30 seconds here, folks. View. Full screen. All right, so to revisit what I said, text is different. Text is not a number. It is a free text. Just checking. Anyone get the joke? Put up hands. Thanks. I already made most of the points on this slide, so now I'm just going to move on. Sorry, going to move on to my top 10 list as promised, now that I've talked about how text is different. So, Paul Schaefer, top 10 drum roll? No thanks. Number 10 on the list of how text is different, or the pitfalls you can fall into with text, is being English-centric. What does that mean? It means, and in the last 15 years, I have heard people say these thoughts to me, I kid you not. Well, the only useful thing to do with text that's not in English is convert it to English, and then you can work on it. Okay, I have heard that numerous times. And the other one is, why don't those people just use English like us? I've heard that several times. Okay, in the real world, there are, in fact, 165 relatively common languages and many more not so common, and then there's Klingon and Esperanto. There's lots of languages out there, and people use them. People do speak Klingon. And you need to think about the text in terms of what people are doing in that language. The only valuable thing to do with text in Hebrew or Chinese is not just to convert it to English or hope that the Chinese people magically next year just all convert to using English. It ain't going to happen. You have to deal with it in the native language. Drum roll, number 9. This has to do with an implementation. This is a problem we see, and this goes to almost any data analytics problem, is designing your solution for where the compute needs to be, how much data you're moving around. So one not so uncommon example is people who design systems where they're going to use an online SaaS provider for text analytics, and they intend to slurp in, say, a huge portion of the Twitter fire hose. Well, that means you're taking a lot of data and you're going to pump it over the internet back and forth. That is incredibly wasteful. That's a case where if you actually have access to that, you almost certainly want to do that ad analysis as close as possible to where you're storing the data. The other case also pertains where you're doing it on-prem. You may have a light-duty application, or there may be a tricky deployment, and you're just better off using SaaS. This should be motherhood and apple pie, but it is a mistake that we've seen. Number 8 on the list. Not considering how your genre domain may differ from that for which the model was built. When we build our text analytic tools, we build them against a particular genre type of text. It may be news text, it may be short strings, it could be EHR data, it could be any of the above. And models do what they do. They learn things from what you've told them. And if you have trained it on EHR data and then you go try to deploy it with a bunch of mongoose, you're in trouble. If you try to deploy it for tweets, you're in trouble. It's not going to work well. There are things you can do to improve that situation, but you have to be aware of this problem. Make sure you tune it to the right space. Number 7. Any linguists in the room? This example on the right is 8 successive repetitions of the word buffalo, and it is completely grammatical. Linguists love this example. It demonstrates human language, in particular English language ambiguity, brilliantly. The buffalo, I'm not going to decompose it for you. You can go search out on Wikipedia. Buffalo, 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 I think I got it right, is in fact completely grammatical. There's a noun in there for the animal. There's a proper noun for the place in the city in New York. Buffalo means to impose upon other people. Why is this up here? That's a really interesting example. It's really cute, Steve. What's the point? The point is, if you have built, let's go back to what I just said. If you've built a model for, say, evaluating physician comments in an electronic health record, and you decide you're going to test it by putting this perfectly grammatical sentence in, you're wasting your time. Right? There's no point. That may be grammatical, but it's not interesting. It's not appropriate. And you might think, this is completely stupid. Why are you wasting my time here? I have seen this done. Not with this example. I've seen E.E. Cummings poems pasted into some of our text analytics technology, which was designed for news. And you know what? And people say, your stuff doesn't work very well. Well, of course it doesn't. We weren't trying to analyze E.E. Cummings poems. We weren't trying to analyze buffalo, buffalo, buffalo. Number 6. We focus a lot in our company on entities, entity extraction, and we have met people who have failed to distinguish this. We actually did for a while. Entity extraction is finding the names of entities, things, people, dates, whatever in your text. And that's great. It's very useful. But it's only half as useful as figuring out which things you're actually talking about. So to be able to say in a news text that there's reference to somebody named Clinton is kind of interesting. To be able to say that that bit of text or a corpus refers to Hillary Clinton, who happens to be running for president, is way more useful. That's resolution. It's figuring out the connecting, or rather it's connecting between the textual information you have and things in the real world. And for the most part, it's that connection to things in the real world that really matters. Okay, number 5, forgetting the importance of overrides. I said that text analytics, when we build our models, we're tuning it to a particular type of text. We do our best to come up with the broadest representation of whatever type of text is required. I think we do a pretty good job. Other companies that do it also do pretty well. As we'll talk about on another slide, it's not always going to be right. And because it's not always going to be right, a lot of applications are going to be upset because there's many applications which just insist, why is it, this actually happened to us, why is it that any reference to God is tagged as a person in our entity extractor? I don't know the answer. I can't tell you why. But I sure as heck know that you have to be able to say, gold darn it, that name is not a person. Let's override it. Let's force it. So when you see God or Allah, then call it a deity. Or just make sure it's not tagged as a person. So overrides are critical. Number 4 on our list. Seeing more and more of this. There's lots of tools out there. Machine learning, send us your data, SAS model, or use some Python tools. You can build a machine learning model. Why can't I just go and build a classifier that's going to do what I want? In theory, you could. What's missing, and this has to do with the nature of human language, is that ambiguity means you have to choose your features carefully. You have to annotate the data very carefully. It takes a lot of work and a large, fairly substantial number of hours in order to get the right data to feed into the model. And in terms of how you decompose your input data, but also how you manage your training data. It takes a lot of work, and you have to understand it really well. You have to know something about linguistics. That's not just me saying that because that means you should buy more of the software that we sell. You can do it yourself, that's great, but you cannot just throw a pile of data at a machine learned system and assume it's going to operate correctly. And it gave us an excuse to put a lolcat up there. So this one is also a great example that's happened numerous times. When you're dealing with numeric data, you can come up, you can either have situations where you have a known absolute, like 2 + 2 = 4. That's simple, and you can be, if you trust math and science, you can be 100% sure you have the right answer. If you're dealing with population data, you can put in error bars of a certain size. Not everyone understands error bars, it turns out. And we've dealt with numerous people through the years who get upset that a particular example of linguistic analysis or annotation or decomposition or tagging hasn't gone right. It's like, but of course I know that Hillary Clinton is a person. It's a bad example. Our software works great on that, but bear with me. Hillary Clinton is a person and your software says it's not. Well, let's go back to error bars. What does it mean to have error? Let's go back to think about this from a statistical perspective. Software that's machine learned, got a statistical model, is not going to be 100% correct. And you can't necessarily, and often you can't at all, make sure that any particular example works, unless you go back to this slide, which is to allow for the overrides. If you have something that's not getting tagged correctly, you may have to put it into an override because your machine learned model isn't necessarily going to do the right thing. The important fact behind this is when you're talking about human language understanding and analytics, people don't agree to better than 93 to 95%. Any two people in this room will understand English or will analyze an English language question problem differently, to a 95% accuracy. And so you really can't expect computers to do much better than that, I think. There's three really interesting interesting products on this slide. I personally am fascinated by all of them. I would love to ride with the Blue Angels. I would love to ride on that motorcycle. I'd probably love to have an Apple Watch. The fact that I love all of them doesn't mean I expect to buy one of the, was it F4? I really don't expect to have any intention of buying an F4. And my wife has no intention of me ever buying a motorcycle. Okay, so the fact that I love those, the fact that I might say wonderful things about them, doesn't mean you can assume that I'm going to do something about it. So you can't just look at sentiment. You have to, in fact, ideally, combine with other sources of information. They may be textual, they may be unstructured, they may be structured rather, information in order to figure out what's really going on here, assuming intent is what you care about. And it often is, because a lot of what we do is about marketing, and marketing is about intent. Okay. That's my top 10 list. Thank you. Any questions? Questions, harangues, thoughts? All right then, well thank you very much. I didn't say anywhere in this talk who this company I mentioned a couple of times is and what we're about, Basis Technology. We sell Rosette, text analytics product that does things like entity extraction, entity resolution, quite a few other things. Stop by our booth, I think it's still open. Thank you.